All right, so let's talk about uranium. Because hidden inside this one single element is this massive story, one that connects the tiny, quantum world of an atom to a toxic legacy that could literally outlast human civilization.
So what is the connection, right? How does one little atom end up creating a problem that sticks around for 100,000 years? Well, to get that, you've got to understand that uranium isn't just one thing. It kind of has two different personalities.
You see, uranium comes in two main flavors, or what scientists call isotopes, U-235 and U-238. U-235, that's the star of the show. It's fissile, which is just a fancy way of saying its nucleus can be split apart, and when it does, boom, it releases a massive amount of energy. That's the stuff that powers nuclear reactors and weapons. Then you've got U-238. This stuff is way more stable. It doesn't split easily, but it's still radioactive, and it makes up almost all the uranium on the planet.
But here's the kicker. Get this. Almost none of it is the useful stuff. I mean, look at that tiny little sliver on the chart. That shows that only 0.7% of all natural uranium is the U-235 we need for fuel. So to get to it, we have to enrich the ore. And that process leaves behind these enormous quantities of the leftover U-238, which we call depleted uranium. And that's where this whole 100,000-year problem really kicks off.
Okay, so we've got mountains of this waste. But the real danger isn't just like standing next to it. The real threat, that's how this stuff finds its way inside our bodies.
See, here's the thing you have to understand. Radioactive atoms, they're not just sitting there. They're constantly changing, decaying, and transforming into a whole series of other radioactive elements. We call these daughter isotopes. It's like this toxic chain reaction. And somewhere down that chain, U-238 turns into something, well, something really sneaky.
Say hello to radium-226. This is one of the key daughters from uranium's decay, and its whole danger is based on a kind of chemical trick. If you look at the periodic table, radium is basically calcium's downstairs neighbor. They're chemically so similar that our bodies, well, they just can't tell the difference.
This trick has a name. It's called molecular mimicry. So if radium gets into your food or water, your body just thinks, oh, great, calcium. It soaks it up and sends it straight to your bones to be built right into your skeleton. And once it's locked in there, it sits and decays, firing these high-energy particles right into your bone marrow. The factory that makes all your blood cells.
And an alpha particle on the loose inside your body, it's just devastating. Outside your body, your skin would stop it, no problem. But now, there's nothing in the way. It's already inside the target, acting like a tiny cannonball, just smashing into your cells and shredding DNA from the inside. And that kind of internal damage, that's what triggers things like leukemia and bone cancer. Now, let's zoom out from the single cell to something much, much bigger, the scale of an entire community. And that brings us to a really tragic story, the largest accidental release of radioactivity in U.S. history, the Church Rock disaster. 94 million gallons. Think about that, 94 million gallons. What happened was, on July 16, 1979, a dam holding back a pond full of uranium waste on the Navajo Nation, it just broke. A flood of acidic radioactive sludge just poured into the Puerco River, which was the lifeline for the local communities and all their livestock. But here's the crazy part. Have you even heard of this? Because just 4 months earlier, you had the 3 Mile Island accident. It released way less radiation, but I mean, just look at the difference in media coverage. 3 Mile Island was everywhere, a national panic. Church Rock, which contaminated 80 miles of river, almost a complete ghost in the media.
And the chemistry of the spill made a terrible situation even worse. This sludge was super acidic. We're talking a pH of 1. That's basically battery acid. And that acid dissolved all the heavy metals in the soil, letting all that toxic contamination sink deep into the groundwater, poisoning the water supply for generations to come.
Okay, so this catastrophic failure of containment brings us to our biggest zoom out yet. We have to stop thinking in terms of years, or even centuries. We need to start thinking in deep time. And the concept that rules this incredible timescale is called half-life. It's just the amount of time it takes for half of a radioactive substance to decay. And the wild thing about half-life is that it's a fixed probability, a constant. There's nothing you can do to change it. You can't speed it up, you can't slow it down, you can't burn it, you can't freeze it. That clock is always ticking, and it is absolutely relentless.
So just how long are we talking about? Well, the half-life of that U-238 we've been talking about, it's 4.5 billion years. That's about as old as the Earth itself.
The waste from that one spill at Church Rock is going to be dangerously radioactive long after our cities have crumbled to dust. When you look at this timeline, our entire human history, all of it, it's not even a blink of an eye.
And that really gets to the heart of the problem, doesn't it? I mean, think about it. We got maybe one generation's worth of energy out of this stuff, and in exchange we left behind a toxic legacy for, what, 100,000 generations to deal with?
Which brings us to one last absolutely mind-bending challenge. If we're going to bury this stuff deep underground to keep people safe, how in the world do you warn someone 10,000 years from now to stay away?
I mean, really think about it. We can barely make sense of English from just 1,000 years ago. You put up a skull and crossbones. To us, that means poison. To a culture in the future, maybe it means pirates. Or who knows, maybe it's just a cool retro fashion statement. How do you create a warning that survives the decay of not just materials, but of meaning itself? So back in the 90s, a whole team of really smart people, scientists, linguists, you name it, they actually tackled this exact problem. And their solution was pretty brilliant. Just bypass language altogether and speak directly to our primal fears. They proposed using hostile architecture, things with names like the landscape of thorns or the spike field. We're talking about huge, jagged structures that are designed to feel deeply unnatural and just wrong, to make you feel scared on a gut level. Yeah, the whole goal is to create a place that just feels wrong. You know, the kind of place that gives you goosebumps, and the only thing you want to do is turn around and get out of there. Fast. No signs needed. The message is the feeling of pure dread itself. And even the actual words they suggested writing are designed to push people away. Because if you write danger, do not enter, you know someone's going to get curious. So instead, the message is meant to convey total and utter worthlessness. It's basically trying to say, look, there is nothing of value here. Seriously, nothing for you. Just go away. And so that really leaves us with one final big question. Everything we decide to do about this atomic legacy, it's going to echo for thousands and thousands of years. We're building the ancient ruins that people will discover in the distant future. So the real question isn't just about how we send a warning. It's about what kind of ancestors we actually want to be for them.